probably get kicked off here. We may have a couple of additional folks wander their way in. Just a couple of housekeeping notes from courtesy of Matt Valdez. Welcome everyone to Wasp San Antonio. Tomorrow is B-Sides San Antonio. It's which you can find at bsidessatx.com. It's at St. Mary's University. It is currently sold out, but for $10 at the door in cash, they might just let you in. So there you go. You have that on the authority of an email that was forwarded to me from Matt Valdez. So
you drive all the way out there and find out the hard way.
Exactly. But Matt Tesoro is speaking, so that's always, as folks that have seen him speak here, that's always a great time. The next OWASP San Antonio meeting is apparently me speaking, with a question mark after it, and a date that I'm not going to tell you. Keep an eye on the meetup and the mailing list, and we'll send that out. It probably will be me, because I promised I would do the next one. I just need to make sure that I'm actually in town for this before I tell you a date. For folks who are on Twitter, we have the OWASP San Antonio Twitter, at OWASP San Antonio. We're also periscoping or whatever here, as long as that's all right with you.
That's cool with me.
Excellent.
First time for everybody.
Yeah, and then we turn it into like a whatever YouTube video or something. So, and OWASP San Antonio mailing list is OWASP-San Antonio list.owasp.org. So that's how between that and meetup, those are the easiest ways to keep track of what we're doing. So without further ado, we'll bring Kunal out here. He's the co-founder and CTO of Previty, next generation web application security platform. Prior to that, he was the director of technology at BBC Worldwide. And prior to that, he worked in various security, data, and engineering roles at Gravity, MySpace, and NASA's Jet Propulsion Laboratory. So take it away. I heard, and just as a preview, I was up in OWASP Boston. I think you had been there the month before. And they had great things to say about your talk. So,
awesome.
So thanks for making me look bad in Boston. Thanks for letting me underwhelm the Boston crowd.
Sure. Thanks for having me. It's an awesome community. So my talk is called Visualizing Security. My wife and I are huge sitcom fans, so we love the show How I Met Your Mother. So hence the cheesy title, When AppSec Met LangSec. Dan already mentioned a little bit about my background. So I started off my career not in security at all, at a place called NASA. And I worked on all sorts of projects. I don't have a software engineering degree. I don't have a CS background. I don't have a CS degree. And I got into NASA working on business applications, writing code for their business apps. Who remembers a programming language or writes in a programming language called Cold Fusion? Right? Yeah, Cold Fusion, right?
Yeah. Wow.
So I got hired to write Cold Fusion apps at NASA. And it was kind of fascinating because when I got there, it's very much structured like a meritocracy where if you don't have a CS degree, they won't let you work on other applications or other things. And so I had to really prove myself when I got there. And that was kind of my foray into the depths of computer science. And I had great mentors over there. One of my mentors, he's now passed, but he was the head of planetary protection. And an amazing, amazing gentleman who also put up some things in the past, back in the days of BBS, so I know there's some folks here that have gray in their beard, gray in their hair, the instructions for how to build an atomic bomb. That was my mentor. And so an insanely smart, self-trained computer scientist and physicist and engineers, all self-taught. And he was my mentor, and he taught me something really interesting on my very second meeting with him. And he said, you know, there's a funny thing about security. You think everything is fully secure, and it's really not. And I'll give you a good point. We know that the Russians and the Chinese have been in our networks for years, and we know exactly where they are. And I was like, well, why don't you do something about it? I'm 20 years old. I'm freaking out over here, going like, why don't you do something about it? And he's like, no, we know exactly where they are, and that's exactly where we want them to be. We can understand, we can monitor, we know exactly what they're doing. The moment we change a strategy, we know they're going to go somewhere else. So that was my first foray into big engineering environment, security. And then, who remembers MySpace? Yeah, the social network that time forgot, is that what you call it?
Dan still has a profile for the record.
For my band.
Your band. Yeah, that's
nice. Dan, what do you play?
I actually don't have a band nor am I here.
You got the social engineering,
right?
Welcome.
Yeah, no, great. So MySpace is fascinating. I got there when there were about 50 or 60 million users. And being in Los Angeles at the time, it was a big deal. Like, this is a social network that's growing and booming. also called Fusion. And all of MySpace.com was called Fusion for a very long time, and then they moved that thing over to .NET. And you can imagine at peak, it was millions and millions of post requests per second. And who remembers the Sammy Worm, right? I want you to cover history, but that happened. And I wasn't there for the Sammy Worm. I joined maybe about 8 months afterwards. And when I got there, they hired me to build out a distributed system and to help build out stuff for caching and their distributed network for images and all this other stuff. And I was like, cool, I'm gonna go do this. They got acquired by News Corp. And during that acquisition, they froze hiring. And so when I showed up over there, they'd already hired someone to do that job. And they said, well, we have some stuff going on in security. Maybe you want to go and look at that. And I'm like, I don't know nothing about security here, guys. So I got really lucky because the very first day I started at MySpace, Dan Kaminsky started his contracting work over there as well. He was at IO Active at the time. And I learned everything about internet security from Dan. And I taught Dan everything I knew about languages like Python, computer science, and it was a sort of mutually agreeable thing. And we built a really fun partnership together. And we solved a lot of MySpace's core problems. So cross-site scripting, SQL injection, cross-site request forgery. And we got away from what they were doing, and I'll talk about that in this talk. Years later at the BDC, and now I'm at Previty, co-founder and CTO. And so what we're going to talk about today is stuff that's kind of near and dear to my heart, things that I was working on, that started working on more than a decade ago. So I landed up at MySpace in 2006, and that's where I was really introduced to a lot of this stuff. So 10 years later, and I want to talk about langsec. We're going to walk through an implementation in Java. How many people here have heard of this thing called processing? Yeah. So processing is a data visualization framework. And what I'm going to show you is I'm going to walk you through a toy HTML parser, a tokenizer parser, and then I'm going to show you a data visualization of this thing in action. And it's a 3D data viz. And all the source code for this is on my GitHub, so feel free to go in, pull it, do whatever you want to do with it. Have fun. We'll also walk through benchmarks and performance statistics, because I think benching is super duper important today. Even though hardware's improved, you still want to make sure that code runs nicely, even on great hardware. And then we'll talk about some different ways you can employ and use langsec, so in a runtime environment, like what we do, and a lot of other places. One thing I want to get out of the way. I work at a vendor. This is not a vendor talk. Okay. I believe in the purity of. I believe in the purity of. This is really important, and it's something I say at every single OWASP meetup I go to. You'll only see that Previty stuff in the very beginning. That's it. My goal is to try and talk about cool stuff. My goal is to not sell you anything. Okay? Cool. I'm gonna get that out of the way. So where are we right now as an industry? Paint the portrait. A lot of text on the slide, but I think everyone knows that it's hard. And in application security today, it's really, really hard because we've been relying on different approaches like signatures and heuristics. So signatures being white lists, black lists, regular expressions, heuristics being things like behavioral analytics. They're good, and they're also really hard to scale and hard to level up. So when we talk about signatures, we're talking about literal strings and regular expressions. And there's a lot of permutations that need to be developed. And then what about speed? What about performance? How expensive are these things to manage? And heuristics can take the form of multi-criteria analysis and statistics. So I overheard a little bit of statistics talk when I got in here. So my degree's in statistics, so it's fun to talk about this stuff. Basically, we've got a trend in security over the last few years where people are talking about big data, statistics, and if you've been to the last few RSAs or the last few of the big conferences, machine learning has come to security. What does that actually mean? And for a lot of people, it just means really simple counters. For a lot of other people, it means actual correlations of computing correlation coefficients. In other places, it's doing regressions. Ultimately, where a lot of heuristics get used in application security is around detecting abnormal behavior. What is abnormal? What is normal? That's kind of the biggest sort of retort to that. Now, what is normal is really hard to define, especially in today's world where people are practicing continuous integration, continuous deployment, where applications are changing 10, 15, 40 times a day. I know a bank that deploys more than 40 times a day to production. A bank. They're regulated, and they're deploying to prod 40 times a day. That's insane. And if a bank can do that, can you imagine what a startup down the road is going to do? They're going to be deploying things by just VIing files on a server somewhere. I'm guilty of that in a startup, right? So the thing is, detecting abnormal behavior is really, really hard because no one really knows what normal actually is. Sometimes this stuff works, and sometimes it just can't. So my MySpace story. So the Sammy worm is a fascinating one. So again, for those that don't know, this was the point of MySpace, positive vibes. Who remembers Saved by the Bell here? We wanted people to express themselves in a multitude of ways. We gave them all the latitude in the world, and we gave them 10 different text boxes on a forum, and they could put in anything they wanted to. And I won't recount the motivations or why something did, but ultimately JavaScript could find its way into our databases because people could circumvent our filters. And at the time, our filters were things like regular expressions, right? It wasn't anything special. There were things like bracket script. If I see the word on load or on document on load, if I saw those things, then I would try to go ahead and remove those things. And at MySpace, because we weren't running these regular expressions recursively, every time we did a replacement, we had to replace it with double dots. Because if someone created a script tag and then they put SCRI and then PT on the other side of that, if we removed it, the script tag would come together. So to prevent the concatenated attacks, we did our regular expressions and string replacements by replacing things with 2 periods. Why 2? Because you could still get executions and versions of Internet Explorer 6 with 1 period. A little fun fact. we learned that the hard way. So we were going down that path, and it's really, really, really hard to do. So here's something I like to do. So I was talking about Florida Man recently, the whole meme on Reddit. So alert hi Florida can turn into something like this, right? I can obfuscate it. And this is a really fun tool that I found on the web called JJ Encoder. Take a look at it. It's really, really easy. It's not as hardcore as some of the other JS frameworks. I won't say the name because it's on Periscope and maybe on YouTube, and there's some really, really bad nouns that precede JS. But you can turn anything into anything else. And the problem is, how do you know exactly what this is going to do? And you don't. Now, the way that I always like to tell people is that if you've got signatures from a commercial vendor or any appliance, it means your attacker does too. If you're using controls or relying on regular expressions, let's say for instance that Microsoft is packaging inside Internet Explorer, your average hacker has access to that too. So I'm going to pull up something over here. I've got my Finder window up. So this is pretty cool. Take a look at these regular expressions. Look at these things. This is for processing JavaScript. This is a favorite one of mine. Look at that. That right there is going to, I don't know what that's going to do, right? Think about the cognitive overhead that people have to manage when they're dealing with things like regular expressions. This is pretty gnarly. How about this one? This is for looking for URLs, which could be inside of a CSS attribute or a CSS value. And again, look at this one. So these are the current controls that a lot of us have been deployed today. And we rely on a lot of this stuff, especially in our perimeter-based defenses, like web application firewalls. It's not bad, it's just we do this. And it cuts out a lot of the low-hanging fruit today. So a lot of the drive-bys, if someone's pulling, a simple open source package off the web and they're going to try and nail your application, you can catch a lot of this stuff. But the moment I try and fuzz around it, this stuff isn't going to hold up. And you're going to have to play the game of layering and adding more to this over and over again. And there's some fun GitHub gists that you can look at. One of them is the Internet Explorer XSS filter rules. And they're what they are. Basically, these are the regular expressions that ship in the DLLs that come with Internet Explorer. And this is what Microsoft uses in the DOM to prevent DOM XSS. And they don't prevent 100% of it. Microsoft will never admit that they prevent 100% of it, but it's how they cut out a lot of the low-hanging fruit. So you can find these things on GitHub. So you can see some of these expressions that they have over here where they're looking for permutations. They're looking for workarounds, and they're trying to layer up and level up to prevent against these kinds of attacks. So get back to HackerMan over here. So there's a couple of ways that you can do attack classification. So there's static analysis. So some of us are familiar with static analysis, where there's static analysis of source code, like static analysis of source code, doing things like data flow analysis, chain propagation to see how information is going to flow through an application, what it could do, basically tracking sources to sinks. And then there's dynamic classification. So you're doing things like looking at signatures that we saw, heuristics. There's another piece, which is language theoretic security. And that's what I want to talk about, LangSec. So how can we get away from those signatures? How can we get away from layering up with those regular expressions and go to something else? Or at least look at something else, maybe as a compensating control for that. So I'll talk about the definition here. I'll just throw it back up here and I'll talk over it. LangSec is short for language theoretic security. And I can't take credit for LangSec. In fact, when we started all of this, LangSec was this emerging and has been an emerging methodology. We've been just sort of doing this for a while, and this domain has existed, which is why we're sort of, yes, this is our home. This is what we do. Cool. The idea is to look at input through the lens of its language. So I'll let that sink in for a second while we absorb that weird definition. But the idea is to look at code formally as a program. So when you see something like a SQL query, or you see something like an operating system command, what if you could actually understand what it's going to do in that environment where it's going to execute? And so let's do something on the database side. Can we map what a database query is going to do before it actually executes? And it turns out that query planners and databases already do this. So if you use MySQL, SQL Server, Oracle, they may ship with some of these tools over here, and some of these tools can walk through a database query and show you exactly what index it's going to hit, where it's going to pull all this information from. So it's already breaking this query down into lower level bits and atoms. And why do we do this? Or why do these databases do it? They do it for performance reasons. They do this because they want to find the most optimal way to fetch information from disk or memory. But it turns out you can actually do some really cool things with this stuff, especially from a security perspective. Right? If I could break a database query down into its bits, I could identify commands. I could identify tables. I can also do things like expression evaluation. Right? If I can do things like not only detecting something like 1 = 1, maybe I can take it a step further to do mathematical evaluation. How about 1 = 1 - 1, or 1 - 0, or 2 = 1 + 1, or my favorite being sine of 1 = cosine of 0. Right? Show me any signature or pattern matching solution that can solve mathematical evaluation or do mathematical evaluation. And you can't. Right? The point is that it needs to be a program that's evaluating input as a program would. So it's kind of like this Ouroboros thing, where you've got the head eating the tail and over and over again. It turns out, obviously, all this stuff is really, really valuable for AppSec, not just on the defense, but also the offense. My talk is going to be about defense, but I'll get the offensive piece out of the way. If you can do this, and if you can understand database queries, you can also generate database queries, which means you can generate novel kinds of database queries. You can generate and build better fuzzers than what exists today. Let's take SQL Map. I love SQL Map. As a tool, it does a really cool job. But what if you could actually build more offensive and more obfuscated and more interesting queries that can create different kinds of tautologies using LangSec? So instead of creating a tautology like a 1 = 1, what if I could know, let's say, the vendor of the database that's being used? Let's say this is Oracle or this is MySQL. What if I did things like string concatenation to create my tautologies? Or what if I did specific mathematical operations that are only designed for those target databases? You create some interesting attacks. Some really powerful stuff exists in that realm, in that domain. Again, I think there's a couple of open source projects that are coming up. So I'd be on the lookout for that when it comes to really cool offensive tools. I know from looking at Burp, I can see how you could probably basically shove some of the LangSec stuff into the Burp side of things. And I know on our team, we've been talking about doing some of that stuff. And if we do any of it, we'll obviously open source all of it. Because I think it's just fascinating to try and push the industry towards that domain, because that's where the attacks are anyways moving.
So are you guys gonna, you mentioned BERT, but what about ZAP? You guys gonna work with Simon Bennett?
Yep.
Okay.
Yeah, I mean, I think the thing that you gotta figure out is how you can take a lot of metadata about the target front that you're gonna be attacking, bring it all in, and try to compute different kinds of queries. So it's one thing to know the schema. It's another thing to know, aside from the table layout, each individual column type, because there's other weird things that you can do, which we're actually going to dive into that right now, which is there's this sort of terminology, this lexicon that I'm going to be talking about, so I'll get it out of the way now, and then if there's any questions, just bring it up and we'll dive into it. So there's what's called a formal grammar. So English, SQL, HTML, well maybe not so much on the HTML side, but there's a formal grammar for many of these things. Some of these things are really well defined. So for instance, Oracle does a really, really good job. Say what you will about them suing Google, but they do a really, really good job at publishing their grammars for their databases. Very thorough. They'll post BNFs on the web of this is exactly what our grammar looks like, versus others like MySQL, where there really isn't a formal grammar that you can go to. You can pull the Lex and the Yak files for those things and try to figure it out, but it's not really anywhere. You've got tokenizers, scanners, lexers, parsers, and I'll actually show you a diagram that walks through all of those different phases in a second. And then you've got lexical and syntactic analysis tools, which is more on the validation side of things. We'll walk through that now. The overall gist of LangSec, I'm going to read in an input, so hello world, or input from a user from a front end that's coming to a back end, or input being a database query that's leaving an application, or input being an operating system command that's about to go hit the operating system by the application. And you're going to read that input and you're going to yield a series of tokens. So hello world could be HELLO, and then you can abstract that up, and it becomes hello space world, 3 different tokens. And then you can even abstract that even further. So hello world becomes a sentence, or becomes a phrase. And you can walk that all the way up in abstraction, and eventually you can build a tree. And you can do some really fun things with those trees. And that data visualization I'll show you in a bit, that's around looking at a tree of HTML, but in 3 dimensions. So I talked about it already. So let's say you've got something like I have a flat. You perform lexical analysis, so you get the letters, numbers, punctuations, and words. Then you can do syntactic analysis then. So I have a flat, being a sentence or a phrase. Now, that's pretty much where regular expressions go, right? You can do things with respect to code generation. So this isn't from the realm of natural language. Let's say I wanted to add in a noun. If I know the context in this case is transportation, I have a flat. Well, I can infer or I can assume that it's tire. And you can do things when you have something like a tree. And this is in the context of natural language, but you can also apply this to a security role. So let's talk about scanning. There's what's called finite state machines. So basically what you're doing is you're looping through a series of input tokens and an input, and you've got different states. I'm now parsing a word. I'm now parsing an address. I'm now parsing an input blob, or I'm now parsing something else. And you can just change your state. So in the case of HTML, opening tags, closing tags, potential tags, attributes, attribute values, all of those have different states. You can go forward, you can go backward if you want. There's a lot of these generators that exist. So here's an example set of tools. Antler is one. It's a lexical analysis and parser. It generates both of those, and you write your solution in Java. So let's say you have an informal grammar, you bring Antler on the formal grammar, and it's going to generate an analyzer and a parser for you. So you don't have to generate on either step by hand. If you've got a grammar, and there's a lot of really cool grammars that exist today. So let's say you wanted to do this for MySQL. There's an Antler grammar for MySQL. It may not be that deep, it may not be that good, but if you just wanted to tinker with something and get started, it exists. How about calculators? That exists too. It's a really fun place to start. There's a lot of other tools over here. So Java CC, I have this phrase here, the one that started it all, next to Lex. So if you use languages like Python, PHP, Ruby, you use Lex, because that's what that uses under the hood. Takes your source code, runs Lex, and generates optimal code under the hood for you. You can do this by hand. So I'm going to nod. You can do this by hand if you want to. you need to understand language density there. It's one thing to do this by hand for HTML, and I'll walk you through a hand roll one that I put together for HTML. But it's a completely different thing to do it for MySQL, where you've got lots of different possibilities to branch and lots of different ways that the language could be structured and formatted. Let's go parsing. So now we tokenize a bunch of stuff, so we got a series of tokens. Parsing is about going over those tokens to make a nice data structure. I call it interesting data structure, like a parse tree. And once you've got a tree, you can evaluate it in two different ways. One is top-down on the left-hand side. So for those that have the CS background, that I clearly don't, you have the ability to go top-down and you can go left to right. So basically you can do the evaluation all the way down, or you can go bottom. Two different methodologies. There's lots of papers on this, should you find this interesting and want to explore this, the trade-offs of both, the performance impact of both, and really it comes down to the goal. What path do you want to take down? For the implementation that I'm going to show you in a bit, it's all top-down. It's not bottom-up. Top-down because I was sketching it, and the way my mind works is to think from the top down rather than from the bottom up. But two different ways you can go. Again, there's lots of parser generators that you can also use. So I put Antler back on this list, but there's also Bison. So Bison generates stuff that's used by PHP, which is widely adopted. I mean, everyone that I know that's running in open source land that isn't Facebook is running either PHP, Ruby, Python, or any one of those scripting languages, at least in their own environments. Lemon is one that generates a parser in C, and the app pairs really nicely with Lex. You can also do this by hand. Again, you need to know your use case. And the use case that I'm talking about for parsing something like database queries, I would not suggest writing a parser by hand. And maybe you do if you only care about looking at, maybe I only care if this database query contains a comment for whatever reason. Maybe you're building a security tool chain that says, if I ever see a database query that contains a comment, it's therefore bad. But that's not necessarily accurate. And the reason for that is your database drivers, especially if you live in Java land or in .NET land, your database drivers are constantly sending queries to your database engine using comments. So if you have something that's predicated on just blocking comments, you're going to block good connections, driver pings between your driver in your application and a target database. You're going to block requests to go and, let's say, fetch collations, or show variables, or get your database schema if you're using something like an ORM mapper. So you have to know your use case exactly. So again, if you're going to hand roll, know your language, and figure out if you're going to tune for accuracy or you're going to tune for performance, because there is a trade-off. If you want to be hyper accurate, you're going to be really slow. And if you're going to be really, really fast, you may have to discard things that you want to look at. So for instance, if you're going to try and do deep mathematical evaluation across subqueries, unions, and joins, and fold all those things together, that's going to take time. And you got to figure out what your use case is exactly. So my use case for this demo is an HTML lexicon parser that I wrote. Well, I'm going to show you how it works. We'll walk through the source code, walk through the finite state machine, we'll walk through how we build up a series of tokens, we'll walk through how we iterate over the tree. I'll show you how it works in processing. So visualizing a couple of DOMs. So I think I pulled DuckDuckGo's webpage, Google's page, MIT, some AppSec pages, and I'll show you the visualization of how that's pieced together. And then I'll show you some benchmarks as well, because benchmarks are really important. Because performance, when you're talking about this stuff, is pretty interesting. I couldn't believe it when I stumbled on this years ago of how or why this could be faster than regular expressions, because I was just always under the assumption that regular expressions would be super fast, but I'll show you something pretty cool. So let us go now to this.
Is coding, programming, I mean, they don't usually go off of Mac, but is that a good platform to still go off of, or like for Python and everything, or Windows, so everybody uses Windows, so I'm trying to figure out, most people don't know how to switch between Windows and Mac when you're going off coding, programming, and all this. Is it better for Mac or Windows or what?
Great question. So, I used to be a long-time Windows user, and I switched to the Mac because Apple ships a lot of developer goodies in here. At least they did about 10 years ago, and they've since started stripping away a lot of those things. But there's package management solutions like Homebrew that allow me to bring in the same version of Python that you're going to run on Windows, the same version of Ruby, the same version of PHP, the same version of Java. So I'm running the same programs. I'm just using a different text editor, which you can also use in Windows. So this text editor is called Sublime, and you can use Sublime in Windows as well. But it's a fair question. Everything I'm going to show you is exactly portable. In fact, if I had a VM on here, I could drag and drop these files into Windows, and it would just work.
Because most of the schools I've gone to, they're like, I don't know how to use Mac, I don't know how to use this for any of the Python or anything. I'm like, geez, now you know how to do it. It's like, it's kind of weird. Okay, well, I just want to double check this.
Yeah, no, great question. Everything should be agnostic. And a small side rant, I think schools should not force people into environments. And the cool thing today is that tool chains are tool chains, and they're pretty portable now at this point, at least compared to 10 years ago, where like you had different versions of Python on different environments. So let's jump into this. So there is a HTML document at its root. We're going to walk through an HTML use case. So we call this thing called HTML document, and it's this constructor that takes input, which is a string, and a security policy. I won't talk about the security policy right now. I'll just talk about how the parser works. And so we instantiate an HTML parser, and we pass in an input. And then we call this parse method. So let's go to HTML parser. So HTML parser is this class, and here's the constructor. Takes in an input, stores it, and sets this current position. So remember I talked about we go token by token, character by character. So we started at 0, position 0, so nothing. And we're going to walk this thing all the way till the end. And we're going to build up a series of tokens. So there's a couple of primitive functions that I built up. So end of file. So if my current position is at the input length, I know I hit the end. So we're done. Peek. Take a look at the next character. So don't consume it, just see what it might be. Consume, peek it, and then iterate the position to move it a step ahead. So if the next character is E, pull it in, advance my position. Consuming white space builds on top of those two primitives that you saw above, where if I'm not at the end of my file, and if my current character is not white space, break, otherwise just keep consuming. Which means I don't care about white space. I'm just going to keep eating all this stuff until the end. And then comes the parse method. So the parse method is this giant state machine that we talked about. Depending on what state you're in, you go down a different code path. The total lines of code of this thing, 330 lines. So I'm not talking about something that's thousands and thousands of lines. I'm talking about something that's pretty maintainable. And you can write a lot of tests to cover if your parser is performing exactly what it should be doing. So let's go back here. So there's this abstract thing in here called parse node. So what does parse node do? Okay, well, remember that peek thing? I'm going to check to see if my next character is those opening tags in my HTML. And if it is, then I'm going to call this function called parse tag. So what does parse tag do? Okay, well, opening ankle, let's consume it. If we're not at the end of the file, then what we're going to do is we're going to see if the next character is a letter. And as per the W3 specification, if the next character is a letter, then we're starting an HTML tag. Cool. Otherwise, if it's a /, we know it's a closing tag. So we've got those different states that we're managing. Otherwise, if it's a wild ankle tag, then we encode it. And we push the encoded version of this thing back. Because it's just a stray ankle tag that someone has out in the wild that could do anything. And from a security perspective, we want to make sure things are always escaped. Things are encoded on the other side. So what does opening tag do? parse opening tag. What we do is we create an HTML node. We call this thing called parse tag name. Why it's parse tag name? Creates a string builder and consumes all the letters. That's it. So you can see what we're trying to do here is we define a couple of very basic primitives, and we use those primitives over and over and over again. And this was the most mind-bending thing for me to get over when I was trying to figure a lot of this stuff out, because I would look at the way different languages were implemented, and I had a hard time wrapping my head around, okay, well, how is it doing what it's doing? Start small. And in this case, this is an HTML parser. You could build a calculator parser if you wanted to, parsing a digit, parsing an operator, and making it more advanced as you go. This is in what I would consider the sort of hello world for Langsec, at least in the security domain that we're all in, which is application security. And all this is available, this code's available online. So feel free to go in, pull in, do whatever you want to do with this. Take a look and see exactly how it's doing this stuff. And if you have any questions, all my information's in all the header files, so you're more than welcome to ping me on Twitter or email me if you have anything that comes up about this. So I'll show you now something really cool, which is the visualization of this thing. So this is processing, and unfortunately, I don't think they have a way for me to increase the font size. Oh, they do. That's nice. Okay. So processing is Java. It's a Java application. It allows you to write your data visualization in Java. And it has these very interesting primitives, like I want to paint something or a pixel to the screen. I want to rotate something. I want to allow things to move around the screen. And I built up a couple of utilities for plotting sphere points, for doing things like translations of vectors. So for those that are familiar with OpenGL or come out of the graphics land, if you ever want to geek out about this stuff, happy to indulge. But for those that aren't, it's just a nice, pretty way to draw pixels onto a screen. And it makes it really, really easy to do some of these things. But you still have to, for instance, allow things like OpenGL meshing, translations, figuring out where things should go. So I'll just start this up, and I'm on a MacBook Air, so hopefully I don't melt my MacBook Air running this data visualization. But all right, I'll stop rotation. And what I'll do is I'll show you tag names. So this is a DOM, and this is DuckDuckGo's homepage. So it's hard to see on the right here, but that's a tree of all those nodes that we processed. So that would be, for instance, the text nodes, the tag nodes, the node name. And so I'm plotting all of this stuff. And because I am parsing this thing rather than running a regular expression, I know the depth of where these things show up inside the DOM. So I'm not just plotting these things randomly. I know exactly where they are, which means I can track them. So I know if something is open, I know if something is closed. I know if a closing tag matches a particular opening tag, and I know everything in between there. So I have all this state. This is a visualization of that state. And so I can change my connection type. So you can see the strength of which things connect to each other, how many nodes things run through, from the opening tag to the closing tag. And it's a little hard to probably see from over there. So this is google.com. Right? Now, remember that whole thing about security policy that I was talking about before? Well, I built up a really simple security policy in processing. Let me see if I have it here. So it's a file called policy.txt. So all I'm doing is I'm whitelisting certain HTML that I want to be allowed. A, BR, div, image, span, strong. So rather than using regular expressions like I did at MySpace to try and block bad tags, I'm only allowing the good tags. And I'm specifically allowing tags by name. which is why you see in this data viz over here 2 different colors. The things that I've allowed in blue, and then the things that I haven't allowed in a different color. So I can visualize this delta. And you can take it a step down. I haven't added to this visualization yet, but if I wanted to, I could explode each text exactly. I could go to attributes, and I can explode those attributes open too, and I can look at protocols. Because there's lots of different ways you can sneak JavaScript into HTML, tags, attributes, and protocols. The AppSec California webpage, look at that thing. It's crazy, right? I'll just turn rotation back on. And this is a CPU graph at the bottom, so you can see my CPU basically dying as I load in all these different things. The MIT homepage, rotation's obviously a lot faster. So again, this is just an application of where you can, and how you can use tokenizers and parsers, and after you've built up these sorts of capabilities, what you can do with them. And this is just a toy implementation, a few hours of just tinkering and processing. Again, all this is publicly available to you. So jump in if you're curious about processing, how it all works, and if you have any questions, let me know. So now comes the fun stuff, benchmarking. So how many people here are familiar with this thing called JMH? I wasn't until like the day I wanted to do benchmarking in Java. So this is new for me too. So JMH is this thing that ships with the OpenJDK. I think it also ships in core Java as well, at least part of what Oracle is providing. And you can use it to pepper your methods with annotations, like benchmark. And you can run a command line to then run this program, and what it does is it uses that annotation to run benchmarks on every single method. On CPU, memory, throughput, latency. So you know exactly how much time you're spending doing each amount of processing. So what I did was, I created a bunch of different payloads. I created payloads in the form of text files from 70 bytes to a megabyte. And those payloads contain lots and lots of text and lots of really, really bad HTML in there. So I took, for the larger payloads, I took the ebook. I always tell the story. I took the ebook Alice's Adventures in Wonderland, and I peppered it with script tags and other bad HTML, so it's Alice's Script Adventures in Wonderland. I can throw that up because I think Alice in Wonderland is project group based, so it should be easy for me to tamper with it and throw it up on. I just haven't done that yet. So the payload size varies. And going back to what the benchmark tests actually look like, let me go back here. So there's this file, benchmark.java, that's loading in these different files. And then remember those regular expressions that I was talking about before? For running these benchmarks, all you have to do is put this annotation around it and call your stuff the same way that you would call any other method. So I chained a bunch of these things on my MacBook Air, so I had to comment stuff out just because I couldn't do 2 runs back to back. But I have one run that's running regular expressions. So running regular expressions on a file that contains 1 million lines of input. And I kept doing this over and over and over again. So now to the test harness, what that actually looks like, this 2013 MacBook Air. So it's not great hardware, right? And the regular expressions that you saw, that's from IE 9 through 11. I went to the OWASP wiki, I pulled some stuff out of the OWASP wiki as well. So there's some stuff in there from how to configure firewalls, some basic rules if you can put in application firewalls. And my Langsec implementation is single-threaded. I'm not running not multiple cores, this isn't async or anything like that, it's a single-threaded. So here's regular expressions. So test set of 10 payloads all the way down to 10,000 payloads. So regular expressions do pretty good when you only have 50 regular expressions. On my MacBook Air, I'm getting 11,000 requests per second. Right? That's pretty good. 11,000 operations per second. Sorry, not requests, operations. Pretty good. But you can see the curve as you look at this table. You can visualize as it goes from regex 50 to a set of 10 to even regex 50 to a set of 10,000. Look at that, only 12 operations, just in that one column. I'm not even changing the amount of regular expressions. And it's actually common for people to be in that left column, where they've got large blobs of input that they want to validate. I see this all the time, where there's folks that want to push large amounts of XML or JSON data through a system. How about XML, right? Pushing lots and lots of SOAP XML data through an endpoint that's trying to do or perform these regular expressions. It's pretty expensive. Now comes LangSec. Same implementation, same parser, same thing that you saw. So the regex is at 11,000, LangSec's at 363,000. I'm getting the same security. Look at the delta. It's 30x. So why is that? Why are we seeing that delta? Well, let's think about regular expressions. Each regular expression is a finite state machine. And if you've got a pretty large input, each regular expression is going to have to do its own tokenizing, its own parsing, its own matching. And in a language like Java, strings are immutable, which means that if I'm constantly in the process of creating new strings or new buffers every single time, I'm going to incur some overhead, not only on memory, but also CPU. And as I chain more of these expressions, it's going to compound. That's what we're seeing here. Versus the LangSec approach, I only go through it once. I only tokenize it once. I only parse it once. I never parse it more than once. And the benefit of that means that I don't have multiple trips through the same data structure or the same input over and over again. And it also means that I don't have to play that cat and mouse game that you saw before of defining all those different patterns, all those different regular expressions that I have to maintain. Now, I just have to maintain my own tokenizer, my own parser, which is different. It's a trade-off. I'm not going to say one is easier versus another. It's just different. And that's the point of all of this. This is just a different way to think about things and a different way to do things. So I had to put this graph together, and I couldn't do this without shifting my y-axis to a logarithmic scale. Because otherwise, regexes just don't even show up in this graph. That's how far away LangSec is in comparison. So I want to wrap it up because we're getting close to the end here. There are a couple of practical applications of language security. So one practical application is to evaluate it where you have context. So again, I don't want to talk about my company, but one place where you could do LangSec is in a runtime model. In a runtime model where you're instrumenting an application and you can see input before it goes out to a database, before it goes to a file system, before it goes back out to a web browser, you could run a LangSec implementation. So if I can trap every single database query that's going over the wire, I could run this. And knowing how fast this is, it's going to be very hard for anyone to even notice that I'm even there. Right? Which means that I can break apart database queries in real time. I can understand exactly what a database query is going to do. I can understand an operating system command before it executes if someone is trying to do something nefarious, let's say to get to Etsy password, or if someone is trying to push out content that contains cross-site scripting, or if input coming in contains obfuscated cross-site scripting. I can break all that down. So LangSec is a growing methodology. It's a methodology that's adjacent to pattern matching. It's a methodology adjacent to heuristic-based approaches. There's a workshop that's happening next week in the Bay Area. It's hosted by IEEE. It's IEEE sponsored. It's the LangSec workshop. The people who created the methodology, implementers of this sort of approach, we get together. We get together once a year and we talk about language security, the future of language security and practical applications. I think our company is probably the only one doing anything in the realm of language security. We haven't come across anyone yet. And I think there's a reason for that. It's really, really hard. I mean, I've talked about building a toy HTML tokenizer and parser. How do you do it for MySQL? How do you do it for SQL Server? How do you do it for Oracle? Each one of these grammars are different. And so I think our goal is to work with IEEE to help sort of kickstart this process. What we want to kind of like the Netflix prize for LangSec, where we can have a lot of open and freely available data sets. Because if you're going to build tokenizers, you're going to build parsers, you need test data. How do you know you built the right tokenizer? How do you know you built the right parser? You need data, you need test data. So what we're thinking about doing is contributing large volumes of test data. So large volumes of SQL Server data, MySQL data, Oracle data, and trying to create a Netflix prize of sorts. It's all open. You want to do this out in the open where people can get together and push this forward, because if we can move the needle on LangSec just a little bit, I think we can start to see people take those libraries and package them back in to core frameworks, core languages, which means that we can start to improve the security from within the language and from within those lower level frameworks. And that's what I'm truly excited about. I think LangSec is a means to that sort of vision, that grand vision. But again, I'm probably biased. It's a different methodology, pairs really nicely with AppSec and a runtime model. It's a lot faster. In my opinion, I also think it's easier to manage 330 lines of Java code that has to compile. It's easy to test 330 lines of Java code than it is to maintain even 50 regular expressions, or I don't even know what each regular expression is exactly going to be doing. The question is, how do you evangelize it? How do you bring and how do you talk about LangSec, and what are some other applications where LangSec could be used? So that's really what I wanted to talk about today, is this approach, how you can use it, how it can fit into existing frameworks. It's just a different way to think about things. And what I often tell people when it comes to LangSec is suspend what you know about input validation. Just suspend your judgment about what you know right now. What if you could approach the problem just a little differently? And I think that's what LangSec is, just a different way to approach that problem. So I'll turn it over back to you guys to see if you have any questions or want to dive into any one of these topics.
You have a preferred of the Lexer parser generators. Do you have a favorite or thoughts on, like, use Antler for this stuff, but Lex and Yak for other stuff?
Great question. So for us, all of them come on. For us, we use Antler. Antler is really important for us, primarily because it allows us to generate tokenizers or Lexers and parsers in multiple languages. So Antler supports Java, but it also supports .NET. There's versions of Python that it supports. So the cool thing about it is we can do it in one place and we can generate it in multiple runtimes, in multiple languages. So that's why I prefer it. Lex and Yak, if you're new to this, I wouldn't recommend starting there. Just might be too steep. I made that mistake. So for me, I tried Lex first, and I didn't know anything about Lex. And then before I knew it, I was in the bowels of someone's SourceForge repository, like trying to figure out like how things were connected. And again, maybe it's just my limitation of not having a CS background or not taking the compilers class like everyone else. Yeah, I just don't know.
So you're talking about limited hardware, and you mentioned CPU repeatedly, but how did the memory consumption compare?
Oh, fantastic. The memory consumption is great, and I'm glad you brought that up. I didn't measure it in these slides, but I did measure it in JMH. So it's more than 100x of memory improvement. And the reason is we're not allocating as much memory per string. You only allocate it once. And then you saw the way I was iterating through the positions. I wasn't even creating a pointer to anything. I was just getting at a particular slice, which means that the only thing I was ever doing was getting to a character, which was going to be managed.
So how do we learn more about LangSec? Are there paper out there and stuff like that?
There are papers.
Okay.
Langsec.org. Langsec.org is a good spot. I don't necessarily think though that papers are a really good place to start. And the reason for it is I think the papers, while they're really, really good, still require a lot of domain knowledge. And I think if you're going to get started in a one place, there are a lot of good LangSec implementations out there of looking at different languages or how to parse something. So I would actually take it a step back. Let me rephrase this again. I would take it a step back. I would actually start at the sort of basics of how to tokenize, how to parse. And a really good example that I started with was how to build a calculator. So it's kind of a very primitive thing that most folks end up learning when they are taking the compilers class is how do I read in a series of input, then how do I parse the operators, how do I connect those things? And then after you do that, now imagine if you had that tree, if you saw a certain operator and you wanted to know how that operator to execute, or you wanted to change that operator to something, that I think would probably be your pivotal moment for going from tokenizing, parsing to lengthsec, which is the mutation of that tree. Once I think you get that concept, I think you're anyways beyond those papers. And it would be good to read those papers, but at that point you could approach HTML, SQL, operating system commands, and each one is its own domain.
You could talk about the advantage of lengthsec for the performance and other stuff. So on the other side, what's the pitfall? What's the disadvantage of using lengthsec?
Maintenance, I think. Maintainability. So if you think about it, the majority of security solutions today that rely on patterns aren't deployed by security engineers or security teams. A lot of them are deployed by operations teams. And operations teams, they want to take an appliance, they want to rack the appliance, and then after the appliance is up, they want to be able to augment things, turn things on or off using definitions and patterns. The problem is that that model doesn't apply to lengthsec. Based on what you saw, there's no way for me to say I want to take some pattern and somehow compile it into a format that a lengthsec engine could understand. That doesn't exist. So the trade-off is, while you don't have that flexibility, you also don't play the same cat and mouse game that you would be playing if you were using signatures. So that, I think, is the big limitation. I don't think there's been any research in this domain. We've thought about it. We haven't found a good way to do it yet, where you could take someone's regular expressions that they already had, and could you somehow convert it to be useful in a lengthsec implementation? And the reason why it doesn't work is those regular expressions have no concept of depth. They also have no concept of the boundaries of tokens. So input is input. To them, the whole world is a nail waiting to be hammered. But in lengthsec, you can delineate between the tags and the text nodes and the attributes. So where does that regular expression actually apply? Do you only apply it to the text nodes? Do you apply it to everything? We don't know. So it's a good question. And just opening up a little bit, it's really, really difficult to try and figure out how do you convert a culture that's been really focused on regular expressions to something new. And we haven't figured that one out yet. So I think it's a bigger macro cultural thing that I think we need to think through rather than something that's going to be solved by one person or the team.
But by phrasing it in the operations with the database query planners and optimization, then you're able to basically elevate it to the business unit. And then the business unit can start putting the pressure and saying, all right, this aligns with our other operations techniques.
Right.
And this allows us to provide better SLAs. And then you can get funding.
So there are a couple of ways you can also do it. The other is through development via application performance monitoring. So New Relic, Dynamics, some of the companies that some of us use. The interesting thing is they're already inside your application. They know everything that's going on inside your app. The difference is they don't look at every single request, they sample requests. So they look at, from what we talked about before, from a statistical perspective, they sample every 1,000, every 10,000 requests. They don't look at every single request. The problem is in security, you have to look at every single request. Because anyone can tinker with some header, or they can fuzz some input that comes up at the back end. But that's another gateway that you can go to, which is, could you piggyback lengthsec on top of an APM-based solution? I think they actually have plugins. They have a plugin model for New Relic. I think New Relic has a plugin model, so it may even be possible to take a lengthsec approach and sort of overlay it on top of that.
Good. This question from Charles, who's watching online.
Okay.
Phoning
it in. Phoning it in. Let's go.
They ask, do you have a list of links to all the framework? You just talk about the tools and any papers that you
Yeah, I will, so what I can do is I can email the list, and then we can put it on the wiki or on the meetup, and then we'll have a comprehensive place for all of it. I would say that, again, just to reiterate, langsec.org is a good place, but again, it might be too academic. And I can throw up links to all of these different things that I mentioned in the talk as well, so links to each one of the lexers, the parsers, a couple of getting started tutorials. So there's a couple of tutorials that I used. If folks would find that helpful, I'm happy to throw that up there as well for how to tokenize, how to parse, learning the ABCs of those things. Especially not having read the Dragon book until a lot later in life.
At what point do you introduce natural language parsing in grammar?
It's a good question. Fortunately for us, in this domain, a lot of the data that we're looking at is structured. So NLP is really important, especially when you're dealing with unstructured grammar like free flow conversations. I worked at a company prior to BBC where my job was to build a natural language parser for tweets. So what we built, and that was another extension of all this stuff. So what we were doing was we were processing tweets. So we had firehose access. So every single time a tweet was mentioned, we built infrastructure that could ingest the Twitter firehose, or as Twitter would call it, suck from the Twitter firehose. And we would store every single tweet, and we would look at it in real time. So we would use things like part of speech tagging. We would use a Chomsky-esque approach, where we would chunk and phrase every single tweet, so we knew what was a noun, what was a verb, what was an adjective. And then what we did was we took those nouns and we mapped those nouns against our ontology. And our ontology was basically Wikipedia. We took all those things that are Wikipedia, we put them all over the place, and then we mapped those things together. That's important in that role, but fortunately for us, in security, all the data is already structured, so we don't need to be looking at that.
So in larger environments, how would you normally, or what tools would you normally use to keep configurations up to date? I'm assuming you probably have multiple instances of this running on different types of systems, right? Because you mentioned it can be used for databases and web requests and other things.
So how do you keep this stuff updated?
Yeah, like what, I'm curious if you can share like what you've been using.
Yeah, so the way we package things is everything is in either a jar file or a DLL.
Mm-hmm.
So code execution basically needs to wrap this implementation, which means if you update the algorithms in any way, you have to deploy a new jar or a new DLL.
Okay.
So no configuration changes, but you do have to swap out basically the guts. That's, again, going back to the sort of pitfalls. It's got to be like that unless you take a different form of abstraction, like wrapping it in a virtual machine or anything like that, where you can just sort of opaquely do that. So yeah, I know this is kind of weird to probably go through. I don't know if this is like kind of bad or whatever. I definitely appreciate the feedback at some point, but if anyone has any questions about this, happy to dive right